Next, we will discuss the chi-squared distribution. For every new distribution, we will follow the following template. First, we will discuss the parameters and the properties of its probability density curve. Then we will discuss how to compute the probabilities and find the x sub alphas. The probability density curve of a chi-squared distribution has the following properties. Property number 1, the total area of course is equal to 1. Property number 2, the curve starts at the origin and extends indefinitely to the right, approaching but never touching the horizontal axis. As a result, we have property number 3, the curve is right-skewed. Also, we have property number 4, as the number of degrees of freedom becomes larger, chi-squared curves look increasingly like bell-shaped curves. The degrees of freedom is a single number that determines entirely the shape of the curve, and is called the parameter of the distribution. We would use the following notation to label a variable that has a chi-squared distribution with df degrees of freedom. Let chi-squared be a random variable that has chi-squared distribution with 7 degrees of freedom. Then the probability density curve of this chi-squared variable takes a very specific shape determined by the parameter. Next, we want to be able to find the probability such as this one, and find the chi-squared sub alpha such as this one. Let's make sure we understand the questions well. To find the probability that chi-squared is less than 5.24 means to find the area under the chi-squared curve to the left of 5.24. On the other hand, to find chi-squared sub 0.05 means to find the value, the area under the chi-squared curve to the right of which is 0.05. Luckily, there are many ways to use technology to answer these two questions. In reality, while it is not too hard to use technology to find the probabilities, very rarely one would have to do this task in the applications. However, while it is also not too hard to use technology to find chi-squared sub alphas, this task will be very common in the applications, so it is worth learning how to perform this task by hand. Let chi-squared be a random variable that has chi-squared distribution with 7 degrees of freedom. And let's find chi-squared sub 0.05. The most frequently used chi-squared sub alphas are summarized in the following table. We only need to identify alpha, which is 0.05, and the degrees of freedom, which is 7, and then look for the value in the intersection, which is our desired chi-squared sub 0.05. Let's do another example. Let chi-squared be a random variable that has chi-squared distribution with 12 degrees of freedom. And let's find chi-squared sub 0.01. We need to identify alpha, which is 0.01, and the degrees of freedom, which is 12. Then we'll look for the value in the intersection, and we get our desired chi-squared sub 0.01. How about the alphas that are on the other side of the spectrum? Since chi-squared is not symmetric about 0 and doesn't have any other nice properties, it is absolutely necessary to have a table to summarize such chi-squared alphas. Let chi-squared be a random variable that has chi-squared distribution with 10 degrees of freedom. And let's find chi-squared sub 0.99. We only need to identify alpha, which is 0.99, and the degrees of freedom, which is 10, and then look for the value in the intersection, which is our desired chi-squared sub 0.99. Let's apply this new knowledge. For example, a randomly selected car salesman's annual salary in thousands of dollars can be estimated by a random variable that follows chi-squared distribution with 40 degrees of freedom. Let x be the salary of a randomly selected car salesman. Let's find the following probabilities and compute the 95th percentile. It is given that x has the chi-squared distribution with 40 degrees of freedom, so we can express it this way. And now we can use technology to answer every single question. Let's interpret the results. There is a 30.5% chance that a randomly selected car salesman makes less than $35,000 per year. there is a 13.3% chance that a randomly selected car salesman makes more than $50,000 per year. There is a 44.8% chance that a randomly selected car salesman makes between $40,000 and $60,000 per year. If you make $51,800 per year, you are better off than 90% of the car salesmen. Now we can say that we know the chi-square distribution.